I want to talk about some special angles that we deal with in trigonometry. We've already talked about there's two different ways to express angles, right? We talk about angle in degrees. Here's a 45-degree angle. And angle in radians. There's a pi over 4 angle. But there are special kinds of angles with special definitions that we deal with. And we have some problems that involve those angles, so I want to go over them now. The first two are just actual sort of definitions, but you need to know what these mean because there will be times and problems when you're given this information, and it's important that you know. Sometimes you will be told you have an acute angle. An acute angle, and once again, in this little talk, as we talk about angles, the most common way to represent an angle is the Greek letter theta. So an acute angle is an angle between 0 and 90 degrees if we're talking about degrees, or if we're talking about radians, 0 and pi over 2. So a lot of times if we look at, a lot of times we graph and we sort of think of the possible angles like a circle. Acute angles are here in the first quadrant, right? We call this the first quadrant of a graph. So acute angles are an angle between 0 and 90 degrees, or 0 and pi over 2 radians. There's another angle that is referred to sometimes, and that's an obtuse angle. Obtuse angle is an angle between 90 degrees and 180. So once again, if you think about if this is 0 degrees here, an obtuse angle is over here. So sometimes you will see problems or situations where they talk about an acute angle or an obtuse angle. That's what they're referring to here. So those are strictly definitions. Now let me describe another kind of angle, and this angle actually will involve some problems. Something that ends up being very important, at least the concept in trigonometry, is the idea of coterminal angles. They don't often use the word coterminal angles, but the principle is very important as we start to learn about trigonometry. Let me review quickly. When we are discussing angles in trigonometry, we like to look at our angles. We sort of can sometimes think of an X and Y axis, and we always think of the positive X axis. When we're going to form an angle, we think of the X axis as the initial side of the angle. That's 0 degrees, and then when we form our angle theta, the other side is called the terminal side of the angle. So the angle, is the distance the angle swept out from the initial side to the terminal side. All right. That's a quick review. That becomes important because if you have two coterminal angles are, I shouldn't say just two, you can have more than two. Angles with the same initial and terminal sides. All right, what does that mean? Well, let's look at it. Maybe we'll look at it visually, and then we'll look at it, how to work out the kinds of problems mathematically. So for instance, let me just draw let's actually try and draw a like 45-degree angle. So right, 90 degrees is straight up the y-axis, so 45 is sort of right halfway between the x and the y-axis. So that means the initial side is here, the terminal side is here at 45 degrees. What if we did an angle where, what if I went all the way, hopefully you realize if you go all the way, make one complete trip around, what angle is that in terms of degrees? We learned that's 360 degrees. If you start the x-axis and you sweep out an angle where then you stop once you get the x-axis, you've gone 360 degrees. But instead of that, we're not going to stop at the x-axis. We're going to keep going, and we're going to stop right here. So what is this angle? Well, all the way around is 360, and then I've gone 45 more degrees. So that is actually a 405-degree angle. And this is pretty common in trigonometry. We can have angles where we go all the way around the circle and then we keep going. So here is where coterminal angles come in. A 45-degree angle and a 45-degree angle are coterminal angles. Fix this. Once again, what's the definition that I just gave of a coterminal angle? Angles with the same initial and terminal sides. In other words, they start and stop at the same place. So 45-degree angle starts here at the x-axis and it stops here halfway in between. A 405-degree angle starts at the x-axis, goes all the way around, and stops halfway in between. The initial and terminal side of these two angles are the same. That's why we call them coterminal angles. Just for fun, we've learned about negative angles, right? What if I start here and I end up having a negative angle, and I start here at my x-axis and I go all the way around to here? What angle would that be? That's actually a negative 315-degree angle. So as it turns out, all three of these angles start and stop at the same place. So in a sense, here are three coterminal angles. And because theoretically we can go around and around this circle as many times, how many coterminal angles would there be? There'd be an infinite number, right? We could just keep going around and around, either positive direction or negative direction or positive direction. So that's the principle of coterminal angles. They start and stop at the same place. Now, oftentimes what they will do, and what you oftentimes have in homework, is they will give you an angle and they will ask you to come up with some coterminal angles. So for instance, for this one, here's the kind of typical problem. Find one positive and one negative coterminal angle of a 45-degree angle. All right, well, we've already done that. That's this problem we just did. Now, when they say one positive, one negative, they don't necessarily mean moving in a positive direction or negative. What they mean is the final answer. So they want a coterminal angle that's a positive angle, and they want a coterminal angle that's a negative angle. So for this one, we've already done it. The positive coterminal angle would be 405 degrees, and the negative coterminal angle would be negative 315 degrees. Let's do another problem, and we'll do it strictly mathematically and not actually drawing out the angles. So say we're given an angle of 170 degrees. Find a positive and negative coterminal angles. Mathematically, all you do is you either add or subtract 360 degrees, right? Because that's all we're doing when we find coterminal angles. If you look at this 45-degree angle, what did we do? We added 360. 45 plus 360 is 405. Since we want to finish in the same place, we just want to make an extra trip around. So for a positive coterminal angle, you would take 170 plus 360 degrees. And if I can do this in my head, there's a positive coterminal angle. And for a negative coterminal angle, you would subtract 360 degrees. So hopefully in my head I'm not messing up. So negative 190 degrees. All right, so coterminal angles, not too difficult. Let's do a problem number 2 if we started with angles and radians. So to find coterminal angles with degrees, we add or subtract 360 degrees. What would we do for radians? Well, 360 degrees is what in radians? It's 2 pi. So if we're given an angle in radians and we're asked to find coterminal angles, we're going to either add or subtract 2 pi. So, for instance, let's say we're given the angle is 2 pi over 3. Find a positive and negative coterminal angle. For the positive, you simply take 2 pi over 3 and you add 2 pi. Now this, if you don't like fractions or haven't added numbers and fractions for a while, this is a little more work than degrees. The only way I can add these is to get a common denominator. So basically I need to change 2 pi to have a denominator of 3. Well, 2 pi I can rewrite as 6 pi over 3. So 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. So there's a positive coterminal angle. For a negative coterminal angle, you just subtract 2 pi, which is really the same thing as subtracting 6 pi over 3. And negative 4 pi over 3 would be a negative coterminal angle. Let me do one more problem just for fun. You might see this sometime. Say we're given a initial angle is 7 pi over 2, and we're asked to find a positive and a negative coterminal angle. Now what's interesting is, and I said this a minute ago, but I'll say it again now and you'll see, a positive and negative coterminal angle doesn't mean that to determine the coterminal angle, that means to add or subtract. A positive coterminal angle doesn't mean you have to add 2 pi to get it. What it means is when you go find a coterminal angle, if it's a positive angle, then that's a positive coterminal. For example, if I wanted to find a positive coterminal angle, I could add 7 pi over 2 plus 2 pi. 2 pi is really 4 pi over 2, 11 pi over 2. Now what if I wanted to find a negative coterminal angle? What we normally do, what we've done so far, is you take your initial angle and you subtract 2 pi, which is 4 pi over 2, and in this case you get 3 pi over 2. But here's the question: is 3 pi over 2 actually a negative coterminal angle? I mean, we did subtract 2 pi, so we're sort of moving in sort of like a negative direction. But is 3 pi over 2 actually a negative coterminal angle? And the answer is no, it's not. It's actually a positive coterminal angle. Because when I say positive, I don't mean how did we come up with the angle. What I mean is when you're all done, is that a positive or negative angle? So really what I've got here, I've actually got 2 positive coterminal angles. I mean, if we start with 7 pi over 2, 11 pi over 2 is a positive coterminal angle. 3 pi over 2 is also a positive coterminal angle. I mean, we got these angles differently, but they're still both positive coterminal angles. Well, what can I do to get actually a negative coterminal angle? Well, why don't I start with 3 pi over 2, and let's go ahead and subtract another 2 pi. So let's keep moving in the negative direction. It's almost like I need to keep moving in the negative direction until I end up with a negative angle. So now 3 pi over 2 minus 4 pi over 2 is negative pi over 2. So these are all coterminal angles: 7 pi over 2, 11 pi over 2, 3 pi over 2, negative pi over 2. But this is the only negative coterminal angle. So now that my angle is negative, then I've got my negative coterminal angle. All right, so coterminal angles. I don't think you'll have a difficult time. They're not too complicated to figure out. All right, one more type of angle we need to talk about and the kinds of problems that we have to solve. There's actually 2 types, but they're the same principle. We have these things called complementary and then supplementary angles. So that's why this teaching is called all these different kinds of angles. So we have these things called complementary angles and supplementary angles. Sometimes they'll say just the word complement and supplement. So what's going on here? Now for complementary and supplementary, we always I'm going to say this, I'm pretty sure almost all the time when we have these kinds of problems, it's dealing with 2 angles, not more than 2 angles, just 2 angles. So let's say the angles, we'll just call them angle theta 1 and theta 2. So 2 angles. If I take 2 angles and add them together, and they equal 90 degrees, or of course in radians, pi over 2. Then theta 1 and theta 2 are they're complementary angles. In other words, 2 angles that added together that equal 90 degrees are called complementary angles. Now in the same way, if I take 2 angles and add them together and they equal 180 degrees, or if we're using radians, pi, then those are called supplementary angles. So complementary angles is where the 2 angles, when you add them together, equal 90 degrees. Supplementary angles are when the angles are added together and equal 180 degrees. Now, here's the kind of problem we typically have to do when we're talking about complementary and supplementary angles. And let me express it 2 different ways. Sometimes for an angle of 10 degrees, find the complementary angle. Or, now here's a second way to word it, which means that we're asking the same question, but it's just the wording is different. Find the complement of a 10-degree angle. Same question, just different wording. But I want you to see both so you understand. So for an angle of 10 degrees, find the complementary angle, or sometimes I'll say find the complement of a 10-degree angle. So what they're doing is they're giving you one angle and they're saying, what is the other angle that you can add to the first angle that would equal 90 degrees? So once again, complementary angles are two angles when you add them together equal 90 degrees. If I've got a 10-degree angle, what angle do I need to add to 10 degrees to equal 90 degrees? Well, that one we can do in our head, 80 degrees. What we really did in our head, we took 90 degrees and we subtracted 10 degrees. I say that because sometimes, so for instance, let me give you one you probably can't do in your head. Find the complement of a so here's an angle. It's actually expressed. It's got a decimal part to it. But we're told to find the complement of a 32.16 degree angle. In other words, I got to find the angle that if I add the angle to 32.16, it's going to equal 90 degrees. Well, I mean, if I really thought about it, I could do it in my head, but I wouldn't trust myself. So mathematically, what do you do? Well, the complementary angle just equals, you always take 90 degrees minus your angle. So in this case, I grab my calculator and I would say 90 minus 32.16 equals 57.84 degrees. So there's your complementary angle. Let's do this. Find the supplementary angle for a for a 5, 5, or 6 angle. All right, so something new here. First of all, the angle is in radians. And now we're looking for a supplementary angle. A supplementary, once again, means the two angles add up to be, in this case, pi. In degrees, supplementary is when the two angles add up to be 180 degrees. But in radians, 180 degrees is pi. So once again, this is where, I mean, some of you could do it in your head. I could give a problem that's a little more complicated. But the surest way to make sure you don't mess up, the supplementary angle, in this case, you always take pi minus your angle. Right, just like up here, for a complementary angle, we took 90 minus our angle. For supplementary, and as we work with radians, we take pi minus 5 pi over 6. Well, pi, I can rewrite as 6 pi over 6. So the supplementary angle is going to be pi over 6, right? Because pi over 6 plus 5 pi over 6 equals pi, which is what a supplementary angle is. Now let me give you one more type of complementary and supplementary problem that is a little trickier. Let's go back to a complement, and this kind of problem is only going to be in degrees, and you'll see why in a minute. Find the complement of a find the complement of a 31 degree, 15 minute, 28 second degree angle. So my initial angle is now written in degrees, minutes, seconds. So now how can I determine this? Hopefully you've learned about degrees, minutes, seconds. If not, you can go back and brush up on that. So typically, to find a complementary angle, we learn you take 90 degrees minus the angle. So I'll take 90 degrees minus 31 degrees, 15 minutes, 28 seconds. Now up here, we did this problem. We had the angle as a decimal, and we subtracted it, and we were able to use our calculator, and we got the answer. Here I'm sort of stuck. I'm not sure what I should do because I can't, I've got 90 degrees here. I can't just subtract 31 degrees because I have to somehow also subtract the rest of this angle. So what can I do? All right, well, here's a little, let me show you how we come up with this. It's almost a little bit of a trick, although it's, when you see it, it's not too complicated. Let me start with a 90-degree angle. And just for fun, I can say, you know what? A 90-degree angle is the same thing as an 89-degree angle plus 1, right? 89 plus 1 is 90. So it's like I've just taken this 90 degrees and broken it up into two parts. But then when I do that, instead of writing 1 degree, if you remember what we learned about minutes and seconds, there are 60 minutes in 1 degree. So I'm going to replace this 1 degree with 60 minutes. So really, I could say this, right? 90 degrees is really the same thing as 89 degrees and 60 minutes, right? Because 60 minutes is 1 degree, and 1 degree at 89 degrees is 90. Interesting. But I'm actually going to take this one step further. I'm going to now, just like up here, I broke up 90 degrees. I'm going to break up 60 minutes to where 60 minutes is the same thing as 59 minutes plus 1 minute. But now, one minute is the same as 60 seconds. So therefore, here's what I'm saying. 90 degrees is the same as 89 degrees, 59 minutes, and 60 seconds. Why did I do that? Because now, instead of taking 90 degrees minus this angle here, instead of 90 degrees, let me replace it with this. This is still the same as 90 degrees, but it's written differently. And because it's written differently, it makes it easy for me to solve this problem. So in other words, so instead of having 90 degrees minus this, how about I say 89 degrees, 59 minutes, 60 seconds, minus 31 degrees, 15 minutes, 28 seconds. Because when I do it this way, then in terms of subtraction, what I can do is I can subtract these one piece at a time. In other words, 60 seconds minus 28 seconds is 32 seconds. 59 minutes minus 15 minutes is 44 minutes. And 89 degrees minus 31 degrees is 58 degrees. So once again, the original problem was find the complement of this angle. And the angle was given in degrees, minutes, seconds. Initially, when I do what I normally do to find a complement, I'm sort of stuck. So what I have to do is realize that I can rewrite 90 degrees as 89 degrees, 59 minutes, 60 seconds. And now I can do the subtraction and get my answer. Now, if you were given some kind of ask for a supplementary angle, 180 degrees would be 179 degrees, 59 minutes, whoops, and 60 seconds. The same as up here, except instead of 89 degrees, you have 179 degrees. Right, so that can be a little tricky when students first see this kind of problem. But then you have to realize, instead of using 90 degrees, we can rewrite it like this. All right, so those are some of the kinds of special angles that are used in various problems. Hopefully not too difficult. And this should hopefully help you as you're doing the homework.